So in this video, we are going to talk about an end-to-end project where we will create a data model, simulate fetching from an OLTP system. We will load data into Snowflake. We will run ad hoc analysis using SQL on the loaded data. And finally, we will create some dashboards using Power BI. This project will help connect dots about the end-to-end flow of a real production project. And we will do all this with a two-line problem statement in English language. I will upload all the files to a GitHub repo, and I'll recommend that you actually implement every single step as we move forward in this video. We have a lot of ground to cover, so let's get started. So what are you going to learn after completion of this video? Well, we will generate test data using Python in this video and a lot of it. We are going to extract data from Oracle using Python. We are going to create a Snowflake account. We are going to create Snowflake database, schemas, tables, and a lot of other things. We are going to load data into Snowflake using SnowSQL and the copy command. We are going to query data using SQL in Snowflake. We are going to use it for ad hoc analysis as we saw earlier. And finally, we are going to build our reports in Power BI. So as you can see, we are going to cover a lot of bases in this specific video. Now, what tools are we going to use and are they free? Absolutely. Everything that we are going to use in this video is free to use. We will be using Python as we saw for test data generation. We will be using Notepad++. This is where we are going to write our Python code. We are going to use Excel. So we have used Excel as a reference and we are going to see that as we move forward. We are going to create a Snowflake free account. We are going to push our data and we are going to query from Snowflake. That is also free. And finally, we are going to need Power BI desktop where we are going to create our reports. All this is free and I'll show you in this video how you can go ahead and create them, right? I have used Oracle as well just to show you how you can fetch data from Oracle using Python. It's not mandatory. If you do not have Oracle, you don't have to worry about it. You can generate that CSV manually. You don't have to explicitly extract through Oracle. It's a very small portion. Okay. Now, in order to achieve best from this course, basic knowledge of SQL, Python, and Power BI will be helpful. But if you do not have that background, it is not mandatory. You will see after the completion of this session, there is a lot that you would have grabbed from it. Obviously, since we are working on a confined time limit, explaining every single thing of SQL, Python, and Power BI will not be part of this video, but still we will cover a lot of things. And even if you are not well versed with SQL, Python, and Power BI, I'll still recommend that you see this video completely. Okay. Now let's talk about a simplified DWBI architecture. Why I'm calling simplified? Because in a real project, there are additional things like CI/CD pipelines, the environments, dev, SIT production, and a few other things that I do not want to mention. Otherwise, it will get too complicated. So in a simplified version, we can say we have a bunch of source systems that can be client applications, CRM, some source databases, flat files, and other sources that facilitate our transaction systems of the organization. So from these system, we extract and load our data into a staging area, right? And how do we do that? We use tools like IICS, Azure Data Factory, Power Center, Airbyte, Python to extract data from these OLTP system into a staging area. So here we do not perform any transformations. The idea is to take minimal of the time from the source system, extract that and replicate it as it is in a staging area. From this staging area, and this staging area can be on a on-prem system like Oracle, SQL Server. It can be physically present on an on-prem system, or it can be on cloud like AWS, Azure, or GCP. From this staging area, we transform and aggregate our data post cleaning, and we load it into a DW layer, which can be a data warehouse, a data mart, right, or an ODS. This DW layer would have our fact tables, dimension tables, and the calc table. And we can use tools like DBT, data build tool, to transform our data. We can use IICS, ADF, AWS Glue, Python, Power Center, all of these tools to actually transform and aggregate data as well. Again, similar to our staging area, our DW can also be on-prem or on cloud. Eventually, when we have created our facts and dimension in calc tables, they will be consumed through reporting and dashboarding tools like Power BI, Tableau, and Click. At the same time, we will have some analysts that are going to query the database directly. They'll be responsible for analysis which are needed on an ad hoc basis and are not to be done regularly, right? So this is a simplified DWBI architecture. Why I say simplified? As I mentioned, it does not have any mention of the CI/CD pipeline. It does not have any mention of the orchestration or the scheduling tool, right? It does not have any mention of the data governance and a lot of other things. But if I try to plug everything into a single video, that will be too complicated. This also covers significant DWBI architecture in a simplified way. Now, in this video, what we are going to do, so eventually we are going to create a Power BI dashboard, one or more, and we are going to write 25 or more ad hoc queries in SQL that is going to provide us a lot of data analysis. Okay. How are we going to do that? We are going to get this data from Snowflake. So both Power BI and ad hoc querying will be done on Snowflake, where we'll have our fact and dimension tables. How are we going to load our data from Snowflake? Let's see that. So as I mentioned, we have an on-prem DB Oracle from where, using Python, we are going to extract a CSV file. So the idea is to show you guys how you can, how ETL, ELT tools or Python, right, or any similar language is used to extract data from on-prem system in order to generate CSV files or to directly load into another system, right? That's why, just for demonstration purpose, I thought it would be good to show you guys this. And then ideally, in an ideal world, we will have a number of OLTP system that would provide data to our OLAP system, as we saw through the staging layer, right? We are not going to explicitly create these OLTP or transactional systems just to reduce the complexity of this video. So instead, what we are going to do is we are going to generate a lot of test data. So I have a couple of reference Excel file. Using that and Python, we are going to generate dimensional data, again using Python. Then we will generate a lot of historical sales data, that again we will do using Python. And in order to give you a little more feel how the data comes in a real production environment, we are going to generate more than 90 files using Python that will contain last month or last day sales data. So we will have a historical factual data, sales data, that we will generate randomly using Python. We're going to generate our meaningful dimensional data again using Python. And then we are going to generate around 100 files that will contain sales data through Python. All this data we are going to ingest into Snowflake using SnowSQL and copy command, right? So this is what we are going to cover in this particular video. What we are not going to cover, we are not going to cover the orchestration tools. We are not going to cover the CI/CD aspect of it. We are not going to cover the different environments. For that, I'm going to create different videos so that you have an understanding of, you have a better understanding of how things happen in a real organization. But this, I can guarantee you guys, is going to be a lot of fun information and a lot of fun knowledge as well. So we saw the video components, right? Let's see what will be our learnings from this video. So the first thing is we just saw the project flow in a simplified version, and we saw how we are going to implement this in our project. We are going to create an ER diagram, an entity relationship diagram. We are going to see the table structure. We are going to understand what is star and snowflake schema. We are going to talk about relationships, keys, all that good stuff. From there, we are going to move to Python in order to generate our test data. We are going to talk about libraries of Python. We are going to utilize them. We are going to talk about pandas. We are going to read data from Excel, and utilizing our libraries and pandas, we are going to generate our CSV files, our test data, which would be meaningful, and we are going to load this into Snowflake. We are going to create the account, the free account, from scratch. We are going to talk about basics of Snowflake. We are going to create a database, a schema. We are going to create tables. We are going to load data into Snowflake, and we are going to see how we can connect Snowflake with Power BI. Then we are going to move to SQL, where we will write more than 25 queries of different complexities that will give us meaningful results from the data that we will have, right? It's all going to be scenario based, and we are going to learn with clause, because using that and analytical functions, we are going to reach for our results easily. Finally, we will learn a lot about Power BI. We are going to utilize it. We are going to see what is Power Query. We will create a blueprint of the report in a PowerPoint. We can also use Figma. We are going to create a data model in Power BI. We will create a few calculated columns and measures. So as you can see, just in this video, we will talk about data modeling, we'll talk about Python, we'll talk about Snowflake, we'll query using SQL, and we'll talk about Power BI. So a lot of ground will be covered just from this video. Now let's talk about our problem statement, right? So we are working with an offline retail organization, and listen to this statement really, really carefully, because everything would be generated just from this statement, right? So our organization sells thousands of products using hundred of retail stores to its customer from last 10 years. So the retail organization, it sells thousands of products in offline retail stores to its customers, and the organization has been in business for the last 10 years. The company also has a loyalty program based on the customer sales. So if you buy often, you are part of a group where you are offered certain advantages, certain discounts. So that is also something we need to take into consideration. And finally, we have all this data that we are collecting from hundreds of stores. The CEO wants to generate meaningful insights from this data. So the first line, right? Let's look at it a little more closely. So we are saying the organization sells thousands of products. So the first entity or table we can have is products, right? That's the first thing, product. We have a bunch of product, thousands of them, that we are selling in our retail stores. So the second entity that we can have is our retail stores. So store is our second entity. From there, we move towards customers, right? We are selling our products to customers. We can profile them in order to understand their behavior better. So the third entity would be customers, and we are in business for the last 10 years. So we will have another dimension table, which is date. Now from here, can we gauge anything else? The organization sells thousands of products in hundreds of retail stores to its customer from last 10 years. One very important thing we can gauge from here, but I'll come to that in a moment. The second thing we know is that for its customer, the company runs loyalty program. So we can also capture a dimension table in the form of loyalty program. And finally, the most important is our fact table, our sales table, where we capture every single transaction of sales that happens across all of these stores, right? So these six words, these six entities that we have identified, right? We are eventually going to create them in our database, and we are going to classify them into facts and dimension tables. The one highlighted in bold will be our fact table, and it will contain maximum amount of data. So these are our entities or tables that we would see finally in Snowflake, right? All right, now that we have finalized our tables, it's time to identify the attributes or the column that would make sense to be a part of these tables. For example, a customer table would have customer name, address, date of birth, gender, and so on. So I've listed all the tables as sheet in this Excel workbook, and now let's start populating the column names. We will start with dim loyalty info. For every table, we will assign a unique key which will serve as the primary key of the table. So here, loyalty program ID can be our first column, which will contain all unique values and will also serve as the primary key of our table. Then the second column can be program name, which will have values like gold membership, platinum membership, and so on. The third column can be program tier, which would have values like gold, silver, bronze, and finally, our fourth column can be point secured, which would show the minimum points required to reach a certain level. Now let's move on to dim customer table. Here customer ID will have all unique values and it will serve as our primary key. Then we will have the first name and the last name of our customer. We can have gender as our fourth column, followed by date of birth and email. And then we can capture address related columns, which can come in handy when we perform regional analysis. We will capture city, state, zip code along with country in the customer table. We will also have loyalty program ID as a column, which will serve as a foreign key and will refer the dim loyalty info table. So these are the columns that we will capture in the dim customer table. Let's move on to the dim store table. Here again, store ID will be our primary key. Then we will have store name as our second column, followed by store type. We will also capture store opening date, as it will come in handy to track the performance of new stores in comparison of the old ones. Then we will capture the store address related info, the city, state, zip code, country. Let's also capture the manager name. Finally, I think it makes sense to capture the region as well, so that we can do some regional analysis. And with this, the attributes or columns of our dim store table are also complete. Let's move on to the dim date dimension table, which I think should be part of every reporting data model. We will have the date ID as our primary key, followed by the date column. Then we will capture the day of week, followed by month, quarter, and the year. We will also add a column is weekend to this table. When we will use this table in Power BI, we will add some additional calculated columns to this table. Let's move on to our final dimension table, dim underscore product. Here the primary key will be product ID. Then we will have product name as the second column, along with category, brand name, and unit price as the other columns for this table. We can add more columns, divide or normalize this table further, but we will keep it simple for now and we will just have these columns in our dim product table. Let's move on to the fact table now, which will have the primary key of our 4-dimension tables along with some measures and the surrogate key order ID. Let's name this table as fact orders instead of fact sales. Order ID will be its first column, which is also its primary key. Then we will have the primary key of the 4 other dimension tables: store, customer, date and product, followed by measure columns, which are quantity ordered, order amount, discount amount, shipping cost and total amount. And with these, even our fact table is complete. The columns in italic indicate foreign keys, while the column in bold indicates primary key of the table. Now this is how our facts and dimension tables look like in our ER diagram. If all dimension tables are directly connected to the fact table, which we see in the center, then such data model is referred to as a star schema, where the fact is at the center and is surrounded or connected with all dimension tables directly. If we had only these 4 dimensions, it would have been a perfect star schema. But when a dimension is normalized or divided, or to further simplify it, if a dimension table is not connected directly to the fact but is connected via another dimension table, then we refer to such data model as Snowflake Schema, which is the case here. You see, dim loyalty info is connected to fact orders via dim customer table. Now let's go ahead and build the relationship between these tables as well. We know one product can be sold multiple times. Similarly, a store can have multiple orders. So these tables will have a one-to-many relationship with the fact table. Similarly, more than one customer can be part of the same loyalty program. So the loyalty table will have one-to-many relationship with the customer table. With this, our tables, attributes and ER diagram is also complete. Now let's see how can we generate some sample data for these tables using Python. So here we have the data in the Oracle table. We see that it has 5 rows. We need to extract data from this table into a CSV using Python. We will use 2 libraries, cx_oracle and pandas, to perform this task. Actually, this is a very straightforward process and can be completed in a few steps. We need to import the libraries, establish connection from Python to Oracle by specifying the server details and the credentials. Then we will write our query and we will fetch the data into a data frame using pandas, and finally we will extract it into a CSV file. So let's switch to Notepad++ and see this in action. First, we need to import the 2 libraries. Let's do that. Import pandas, import cx_oracle. Then we need to specify the username, password and the DSN. Let's specify that. Now let's specify our query here. Select star from our table name, which is dim loyalty program. And let's also create our connection object using connect from cx_oracle. We will need to pass the username, password and DSN as input. Now let's use read_SQL function from pandas library and we will pass our query and connection as the parameters. Let's print the data frame to see if it is working fine. This actually looks pretty good. Let's ignore the warning for now. And now we need to dump this data into a CSV file. We will use to_CSV to do that. Since we do not want to load the index column in the CSV, so we will specify index is equals to false here. And now our script is complete. Let's run this one more time and it completed successfully. Let's verify our CSV file as well, and this looks really good. So now we have successfully generated a CSV file from Oracle using Python and pandas. Now that we have fetched the data for loyalty info table from Oracle using Python, we know that it has 5 rows. We will move to populating dim customer table. Before we actually implement the logic in Python, let's see what kind of values are expected in what column, and then we will see how we can populate them in Python. For customer ID, we need an incremental sequence. We will handle all incremental sequence in Snowflake, so we can leave it for now. For first and last name, we need random strings. For gender, we need to choose from a list of options. For date of birth, we need a random date. Then we need a random email, random address, city, state, zip code, and country. And finally, our loyalty program ID can have values between 1 and 5 because we already know that we have 5 rows in loyalty info table. If we can generate one row with meaningful logic and data, we can loop through it and populate as many rows as we want. Luckily, Python has a lot of cool libraries that we can utilize here. The first one we will use in our code is Faker. It allows us to generate fake names, email addresses, dates, and much more. So majority of our columns can actually be populated by methods from this library. In fact, all these columns can be easily populated by this library. Now for the other two columns, we can choose random. It allows us to choose a random value from a list of values and a random integer between two numbers as well. So just these two libraries can help us create a single row of test data. Now all we need to do is loop this logic and we can generate as many rows as we want. Now we know how to generate a single row. We know how to generate multiple rows as well using loop, but we also need to write this to a CSV file. So let's list down all the steps that we need to perform to actually create it. Let's switch to Notepad++. So we know that first we need to generate a random row. Let's write that as a comment. Let's also save this file with the name dimcustomerdata.py. Now once our single row is generated dynamically, all we need to do is loop and generate multiple rows. Next we know that we need to create the header and we need to write the header to the CSV file. So let's add both of these as comments as well. We need to open the CSV file for writing, and we also need to write our random rows in the CSV file. Let's also add a comment to create a section for these. Let's also add a final comment to indicate that the entire process has completed successfully. Now at the very beginning, let's specify that we need to import the Python libraries. Let's also create a section for initialization of objects. Then we should request the users to enter the number of rows we want to write to the CSV file. Along with this, let's also request a user input to add the name of the CSV file. I think now we have prepared all the sections, so let's start writing the code. Even if you do not understand Python well enough, I think you should be able to understand and appreciate these steps. I always try to outline the logic, and then you can search for the syntax online as well if you are not clear on something. Let's go ahead and import the CSV, random, and faker libraries. And now let's initiate an instance of the faker class so that we can use it to generate fake data. Let's store the value of the rows which will be input by the user in the variable num_rows. By default, input returns string, so we need to explicitly convert it into integer using int function. Let's also store the value of the file name in the variable csv_file, and let's print at the very end that the process has completed successfully. Now before we move ahead with further code, let's validate by running to see if we have made any mistake till now. For that, we will open our command prompt and we will change our directory to the one where we have stored the .py file. We will write the keyword Python space and then we will specify our .py file name. When we pressed enter, it showed an error. It seems we missed a bracket. So let's move back to our Notepad++. We will add the bracket and we will save our file. Let's test it again to see if this was the only error so far, and now it's working fine. Let's move forward and open our CSV file. The syntax looks like this. We specify the with keyword followed by open. Then we will specify the file details and the mode in which we want to open our file. Here we want to write to it, so we will choose W. If you are not able to understand this syntax completely, do not worry about it. We will create a separate series of videos on Python. Next, we will create a CSV writer object that is used to write data in the CSV file. Now in the very first row of our CSV, we need to write the header. We know our header has columns like first name, last name and other columns. I'm going to create the header list in Excel and paste here quickly to save time. Let's go ahead and write the header to our file using the writer object we created earlier. This syntax is writer.write row, and then we specify the row which is our header. Let's save our file and test out to see if the code till here is working fine. We will switch to the command prompt and we will specify the input parameters. It seems that the process has completed successfully with no errors. A CSV file was also created in the specified location, and upon opening it we can see that the CSV file has the header into it. So we were able to write our header to our CSV file. Now let's move back to our Notepad++. We will create a for loop which will generate the number of rows the user will input. This is how the syntax will look like for the for loop. And inside this, we are going to do our main task, which is to use these libraries to generate the random test data as we saw in our Excel earlier. So we will start with the first name, which should be fake.firstname. Then we will move to the last name, which should be fake.lastname. Now I do not remember the syntax of majority of these, but we can always correct when we see an error. For gender, we will specify random.choose and the list of values to choose from. We will choose a fake date for date of birth. The same fake would be used for email and phone number as well. Now the address can contain comma, and since our delimiter in CSV is comma, we will replace any new line and comma with space using the replace. For city, state, postcode and country, we will also choose to use the faker class. And for the final one, we will choose a random integer value between 1 and 5, as we know that we have 5 different entries in dim loyalty info. This should complete our row, and let's use the CSV writer object to write this row to our CSV file. Now because this is part of our for loop, it will write to the CSV file as many times as we specify in our input parameter. Let's save this and move to our command prompt, and we will run this code one more time. So after specifying the parameters, we noticed an error. We used choose with random while it should be choice. Actually in Excel I used the function choose, which is how I got confused. Let's correct and save this, and we will run the updated version one more time. I'm sure there are still a couple of issues out there. Let's specify our parameters. Again an observation. I have missed the brackets in front of address. No harm done. Let's rectify it in Notepad++. We will save it and we will test it one more time. Let's specify the parameter, and this time it completed successfully. Let's look at the CSV file that was generated, and it looks really good. Now we can generate as many rows as we want. I can instead choose to generate 10,000 customers, and it will give me the detail of those 10,000 customers. It's gonna take a minute to generate all this data, but you can see it worked fine. So with this, our CSV file for dim customer is ready, and now we can move to the next one. Now we will populate the store dimension. Let's have a quick walkthrough of the columns we need to populate. The first one is pretty straightforward. It's the primary key and we will handle it in Snowflake. The second one is store name and we have made it interesting for learning purpose. So we have captured some adjectives and nouns and we have stored them in an Excel file. Now using pandas, we will read this Excel file and we will store the sheet in a data frame, and eventually we will mix and match these along with the word the to come up with some cool store names. For store type, we will use random and choice. The next few can be handled with faker, and finally for region we will again use random and choice. So let's move forward to Notepad++ and create our dim store CSV file. So right now I've listed comments for every statement that we utilized in our previous script. Here we also need to fetch data from an Excel file, and we are going to do that with the help of pandas. We are going to create a data frame. Then we are going to fetch and concatenate two random adjective and nouns along with the word the to create our fancy store name. So let's see what additional sections are required here. We know we need to fetch the libraries and get the input params, but here we also need the details of the Excel file like the file path and name, the name of the sheet where the data is present, and the column names. Also, we'll have to fetch this data in a data frame, so we'll have a separate section for that. The next steps remains the same. When we go to the loop section, here at this point of time, we need to fetch the random adjective and noun, and we need to add the word the in it. So we'll create a section for it. This would finally be used as our store name, and then we'll write our rows to the CSV followed by the success statement. So I think this is enough with the comments. Let's get started with the actual code. So first we are going to import pandas followed by random, CSV and faker. Then as we did in our last video, we'll initialize an instance of faker. Then we'll take the input of the number of rows from the users, which will suggest how many stores our org will have. Since we want this to be an integer, we will explicitly specify that. Let's also request the user to input the CSV file name as we did in our last video. This code obviously can be improved to a great extent, but I'm trying to keep it basic and simple. So now moving forward to new stuff. So the first thing we need is the Excel file path and its name. Then we need the name of the sheet where our data is present. And finally, we need the name of the columns that hold our actual values, which would be adjective column name and the noun column name. I have all this information handy, so I'm going to plug it now. The sheet name is store name data. The adjective column is adjectives and the noun column is nouns. And this is the location and the name of our file. When you specify these values, please change the location of the Excel file. Now let's fetch this Excel sheet in a data frame. For that we will specify df is equals to pd.read_excel. The first parameter would be the name and the location of the file, and the second parameter is the sheet name. Let's try to print this data frame and check if everything is good till this stage. We will move to our command prompt and we will enter our parameters. Let's add 10 as the number of rows, and this would be our file name. The process completed successfully, so everything looks good for now. Let's add a colon at these two places so that it looks a little more clean. We will remove the print statement as we do not need it anymore. Now let's open the CSV file. We will write the syntax with open CSV_file. We will choose the mode as write and the new line character. Then let's create an instance of the writer object which will allow us to write into the CSV file. We will specify writer is equals to csv.writer and we will pass the file here. Now let's create the header also. I already have the names captured. So we can copy and paste this information. Now we are going to write the header to the CSV file using writer.writer row. And now let's write our for loop syntax to generate the random rows. Our first column is store name. For that, we will fetch the value of adjectives and nouns into two variables. We will specify the data frame and our column name with it. Then we will use sample and values to fetch the random data. Now let's repeat the same operation for nouns as well. Now that we have completed this, we need to get this into a variable store name as the concatenated output. We will specify double quotes, then the adjective and followed by the noun. So we have captured this information in the store name variable. Let's try to print it to see if our logic is working correctly. We will switch to the command prompt. Let's enter our input parameters as 10 rows and test_abc.csv as our file name. The process completed successfully and this is actually looking pretty neat. Now we will go back to our Notepad++ and now we will create our random row inside the for loop. The first column would be the store name we just created. For the second one, we will use random and choice. We will specify a list of values like SMB, MBO, exclusive and outlet as the possible values. For the next one, we will again use fake to generate the date. We will make changes to these dates when we move to Snowflake. We'll see that in future. We will again use fake to generate the address. We know that the address can have comma and new line character. So we will replace that with space. We will replace the new line and the comma with space using replace, right? Then we will populate the city, state and country using faker, and we will populate region again using random and choice. Finally, we will use faker one last time to generate the name. Now our row also is complete. We will use the writer instance to write it to the CSV file, and with this our entire script is complete. Let's test it by moving to our command prompt. We will generate 100 rows and we will write the file name as dimstoredata.csv. Let's run it and the process completed successfully. Let's open the CSV file and this actually looks pretty good. With this, we are done with loyalty, customer and store. Let's move on to the product dimension, which is pretty small and quite similar. So here the first column is pretty simple. It's the primary key that we are going to populate using Snowflake. The second is product name, which we are going to fetch from Excel. We have an Excel sheet where we have stored some random products and categories. We are going to populate both product and categories using it. The fourth column is brand, which we are going to populate using random and choice. We have generated some fake brands that we are going to choose from. And the final one is unit price, which again we are going to populate using random. So we only need to generate 4 columns related to product. Let's move to our Notepad++ and do it. So we are not going to create the entire script from scratch. Rather, we are going to reutilize this script that we created in dim store CSV generation. We are going to copy and paste it here. So what exactly needs to change? The libraries can remain the same. The initialization is fine. The input is fine. The Excel file and path is fine, but we have to change these things. We have to change the sheet name and the column names. We also have to update the headers as they will be different. I don't think we need to calculate any of this, so I'll delete these lines. The same goes for row as well. We will not need majority of these columns. I'll just need random.choice for my brand, so I'll keep that. I think the below part remains the same. So if we change these components, I think our script should run fine. So let's go ahead and do it. So the first thing that we need to change is the Excel sheet name. It's not store name data. Similarly, we need to change these column names as well. It should be product and category. instead of adjective and noun. Now these two columns are part of two different worksheets in the Excel workbook. So we will have to give our Excel sheet clear unambiguous names. Let's call this one Excel sheet product, and let's create a new one. We will call it Excel sheet category. Now I'm going to get these values from the Excel lookup file I have. So I've pasted these values. The name of the Excel sheet for product is raw product names. The column name for product is product name. The Excel sheet for category is product categories, and the column name is category name. Now we need to change the sheet name in our data frame. Let's grab this product sheet name and paste it here. Since we have two different sheets, now let's create another data frame, df_category, and here we will change the sheet name to correspond to the category. So everything looks good here. We have created the two data frame. Let's change the header as well. We know that we need 4 columns: product name, category, brand, and unit price. Let's specify them as our header. We're going to write our header to the CSV. And now we have to actually populate the product name, category, brand, and unit price. So we will get the product name first. We will use the df data frame. We will use the product column name, and we are going to use sample and values again. We will specify n is equals to 1. So this will provide us with a random product name from the Excel file. We can actually copy paste and get the category as well. Let's change the data frame and the column as well. Rest can remain the same, and this would give us a random category. So now we are done with product and category. Also, I've generated some fake brand names, but still, to be on the safe side, I'm going to add fake in front of all of them, and we are going to populate them using random and choice. So this should give us brand as well. For unit price, we will pick an integer value between 100 and 1000. So after this, our row should be ready. Here we are writing the row to the CSV, and with this our process completes. So we should be good. Let's review real quick. We are importing the libraries. We are initializing fake, but since we are not using it, let's go ahead and remove it. Then we have the input parameters, which are fine, the details of the Excel file, which are fine as well. We have these data frames, they also look good. We have the header, we are writing it to the CSV, then the for loop and the row generation with random data. So all of this looks good. Now let's move finally to our command prompt to see if this executes successfully. I'm going to specify the keyword Python followed by the name of our file. Let's try to generate 100 rows, and we are going to specify the file name as dimproductdata.csv. It completed successfully. Let's see if our product data was generated successfully. Actually, this looks pretty good. Obviously, this is fake, so it's not perfect, but our intention was not to make it perfect. So now with this, we are done with dim loyalty, store, customer, and product. Let's move to the date dimension now. So now we have moved to our final dimension, dim date. These columns are pretty self-explanatory. This is one of the simplest dimension. In fact, we are going to create it using one single library in just 7 steps. Since these columns are pretty self-explanatory, I'm not adding anything in front of them. Rather, let's see how we can create them using pandas in just 7 steps. As I mentioned that we are going to use just one library. So the first step would be to import the pandas library. In the second step, we will choose the start and end date between which we need to generate our series of dates. In the third step, we will actually generate the series of dates between our start and end date. In our fourth step, we are going to convert this series of dates in a data frame which means we will have a row and column structure. Then in the step 5, we will add the additional columns that we have captured in our Excel file. In the step 6, we will reorder the columns so that the date ID becomes the first column. We will see why this is required as we progress. And finally, in the step 7, we will write the data frame to a CSV file after excluding the index column. So without any further delay, let's get started. We will import the pandas library. Then we will specify the start and the end date. Since we started the business 10 years ago, we will specify 1st January 2014 as the start date and 31st December 2024 as the end date. Now we are going to create the series of dates based on our start and end date. We are going to use the date range function provided by pandas that takes the start and end date as input and generates a series of dates between them. Let's see this in action. We will switch to the command prompt. Let's execute our Python file and we see that the series of dates have been generated. Now as a part of our next step, we need to convert it into a row and column structure, and we will do that using data frame. So let's switch back to our Notepad++. Let's generate our date dimension or data frame. We will specify the date range as our data and the date column as our column name. Let's also print this to verify if the data was indeed transformed in a tabular structure into rows and columns or not. So we will switch to our command prompt and we will run the Python file one more time. We can see our series has been transformed into tabular structure with proper rows and columns. Now we need to add the additional columns that we had in our Excel file. Let's do that in our step 5. So we need to add day of week, month, quarter, year, is weekend and date ID. How do we create it? We just specify the date dimension data frame and we specify the column name we want to create. Since we need to create it using the date column, we will specify that and we will use the accessor dt to access the day of week property, which will return a value between 0 and 6 depending upon the day. Let's switch to the command prompt to verify if the new column was indeed added to the data frame. After running the script, we do see it here. Now we can go ahead and add the month, quarter and year in a similar manner. They follow a similar syntax. Let's do it quickly. For is weekend, we are going to use day of week. If the value is in 5 or 6, then it's a weekend and it's going to return is true, else it would be false. The syntax will remain similar. And finally we need the date ID. Here again we will transform the date by formatting it as YYYYMMDD. We will use string format time and we will transform it to an int. This is how the syntax would look like. Now all our columns are ready. Let's move to the command prompt to test them and see the output. We will run the script and now we see we have calculated all the required columns. Now we just need to reorder them so that the date ID becomes the first column and the others can remain as it is. For that we will create a new list. It will first contain the date ID and then we will concatenate all the other column names from date dimension apart from column ID to this list. This way date ID will become the first column. Let's switch to the command prompt and test it out. We will run the script and we see the output. It is giving us the expected result. Now we just need to plug this in our data frame and the reordering will be complete. Finally, we need to export this data frame into a CSV and we need to ignore the index column. Let's do this using to_CSV method. This is how the syntax will look like, and with this our date dimension code is now complete. Let's switch to command prompt and run this one final time. The process has completed successfully. Let's look at the dimdate.csv file, and everything looks as expected. You may notice that in my machine we see ddmm instead of mmdd. We will handle this when we load this data into Snowflake. With this, our date dimension part is also complete. Let's see the columns of our fact table and the values it can have. You may notice that the columns are slightly reordered, but we can ignore that. So we know that the first column is the primary key, and we can handle that in Snowflake. The date ID can have values between 1st June 2014 and 27th July 2024 in this particular format. We are selling thousands of products, so our product ID can have values between 1 and 1000. We have 100 stores, so our store ID can have values between 1 and 100. We are assuming 1000 customers, so our customer ID can also be between 1 and 1000. Let's choose the order quantity to be between 1 and 20 and the unit price to be between 100 and 1000. These columns are pretty straightforward and they can be easily populated with random values. The discount percent can be between 2 and 15. So we will calculate discount amount on the basis of that. Similarly, the shipping cost can be between 5 and 15%. We will calculate it using this. The total amount would be ordered amount minus discount amount and shipping amount. These three columns are dependent on another column, so we need to calculate them. They are not very complex either. We can calculate them pretty easily. We just need a little effort in populating the random dates between our 10-year date range, because we need to populate that in a specified format. But we will achieve this as well. So let's switch to our Notepad++, and we are going to do it using two libraries, Pandas and NumPy. So we have imported the libraries, and here is a list of columns that we need to generate along with what logic we will use to generate these columns. Now we will request the user to input the number of rows we want to generate, and now we need to generate a list of dates between our start and end date so that we can choose random date between these. For this, we are going to use array range function from NumPy library, which will generate our date range. We will specify our start and end date. Now the function will not work with these string values, so we will have to use numpy.datetime64 along with our date strings. And now let's go ahead and print our date range to see if the function was completed successfully. Let's switch to the command prompt. We will run our script. Let's specify 10 as the number of rows. And now we see that the date range has been generated successfully. Notice that we gave 28 as the end date, but it excluded the higher value. The maximum value that we see is 27th July. Now let's move back to our Notepad++ and select random dates from this series that we have just generated. For this, we will use random and choice functions of NumPy to select the number of values based on the number of rows we have entered. So we will write np.random.choice. We will specify this as the first parameter, and then we will write size is equals to num_rows. Let's change the name to random_dates and let's print it to see if our code till here is working fine. I chose Notepad++ so that you do not have to install extra things. I know it can be a little painful to switch between windows, but I hope if you are a beginner, it would be helpful. Let's run our script. We will specify the number of rows as 10, and we see 10 random dates being shown, which is pretty cool. But now we need to convert this into int date ID format. So let's work on that now. We will use pandas here and the string format time function. This would be our format string, capital Y, small m and D. Let's print the formatted rows as well to see if it's working as expected. Let's run our script and we can see now we have the date ID in the expected format. Now let's move on and generate a dictionary, a key value pair where the key will be our column name and the value will be an array of actual data that our column should have. So the first column we need is date ID, which we have already generated. So let's write that here. The second column is product ID and we will use random function from NumPy to generate random integer values using randint. We will specify the lower bound as 1 and the higher bound as 101. Because we know it does not consider the highest value, and we will generate the array size on the basis of number of rows we want in our CSV. This is how the syntax would look like. Now the next 4 columns, store ID, customer ID, quantity ordered and order amount, can be generated in the same manner. So let's copy paste this 4 times. Let's change the column names here. Also let's change the lower and upper bounds. We know we have 100 stores, so we will change store to 101. We know we have 1000 customers, so let's make it 1001 for customers. For quantity ordered, let's change it to 21, and for order amount we want it between 100 and 1000, so let's change it accordingly. Now let's print it to see how it's going to look like. Let's run our script. We will specify the rows as 10, and now we see that along with our column names, arrays were created that hold 10 values based on the logic that we had written. Now that we have the required data, let's transform it in a tabular structure using data frame. We will write df is equals to pd.dataframe and we will enter our data here. Let's see how our data frame looks like. We'll run this script one more time and our rows and columns actually look pretty damn good. Now we need to calculate the discount amount. We know that the discount percent can be between 2 and 15%. So let's create a list of discount percent that will have the exact values as the number of rows we have. We will utilize NumPy random to generate this. Let's specify the lower and upper values and the size as per the number of rows. We can actually copy paste this and create our shipping cost as well, which we know is between 5 and 15%. So let's do that here as well. Now we just need to add these columns to our data frame. We have already done that in our date dimension, so we know the syntax. We can specify df along with the column name that we are trying to add. Then we will specify equal to, and the logic we need to create the column, which in this case is the multiplication of order amount with discount percent. We can again copy paste this and calculate the actual shipping cost as well in the same manner. Let's change the column name and replace discount percent with shipping cost percent, and we should be good. Finally, the total amount column is to be calculated by subtracting the discount amount and shipping cost from order amount. Let's do that as well, and with this our data frame should be completed. Let's print it and verify one more time before we dump it in a CSV. We will run our script and we will only generate 5 rows, and this looks really good. We have all the columns now. We are ready to generate our historical store data as well. Let's dump this in factorders.csv file. We will ignore the index column. Let's run the script one more time with 100,000 rows, and it completed successfully. We will verify this in our CSV file, and our CSV file look good as well. So we have generated all the facts and dimension table test data. Let's look at one more scenario. In the real world project, once the store are closed every night, the OLAP system would get sales file from each store, and that would be loaded overnight using a batch job. So let's create 100 more files with only last day data, one for each store. We will tweak this script a little to generate as many files as we want. So here is an exact copy of this script we created for our historical data. In this, we need to change a few things. The first thing is that we do not need dynamic date IDs. Rather, we need a static value for yesterday. So we can remove all this code and we can specify the static value here. Now we need the value to have the same size. So we will multiply it by the number of rows, and now it will have the same number of entries as the other columns. We also need to change the store ID. We do not need a random value here. Rather, we need a static value based on the file name. For the first store, the value should be 1 and so on. So to achieve this, let's write our for loop. We know we have 100 stores. So let's keep the range till 101. And now we can use I in our store ID column. We again have to multiply it by the number of rows so that we have the same number of entries. Now since we have introduced the for loop, let's add the indentation, and this looks much better. Also, we do not need to prompt the user to enter the number of rows anymore. Rather, let's generate dynamic rows for each of the file, and for that we are going to use random and rand init. So let's go ahead and change our code. We'll remove it from here. Let's paste it here and we will write our syntax. And now every time a file is created, it will have random number of rows between these values. Another thing that we need to tackle is we cannot have a static file name now. Let's change this to file path, and this file path will have the location and the name of the file. Let's specify an explicit directory path where we'll generate all these files. This will not change, so let's declare it at the top. And now let's generate the dynamic file name as well. We will use store ID and the date ID in it. So we will specify file underscore name is equals to F, then we will specify store underscore I. Now instead of writing the value here again, let's specify it at the top in a variable, and we can use it at both places. Let me make this change. So now date ID is equals to 20240728. Let's change this in the dictionary as well, and we will also add this in the file name. Now in order to join this, we will use the OS library. So let's import it first, and now we can join the directory with our dynamic file name. We will write file path is equals to os.path.join. We will specify the directory and file name as our params. Let's also add a check. If any of the file already exists, we will remove it and we will write it again. So here we will write an if statement which will check if the file exists. Here is the syntax. If os.path.exists with the file path, then we will remove it using os.path remove. With this, our script is completed. Let's switch to the command prompt and we will run the script. It is writing data to all our files and the process has completed successfully. Now let's go to the folder and the files look good. Let's open one of the file, and this looks good as well. With this, our Python part is complete. We have generated the entire test data. Now let's set up the Snowflake account and load this test data into a Snowflake database. So in order to create the Snowflake free account, open your browser, type Snowflake account creation, and you should see a screen like this. Click on sign up for Snowflake. Specify your details here as requested in the form. You can enter your personal email. Business email is not required. No banking details are required either. Thank you Snowflake for this. Click on continue. Now you can choose the Snowflake edition from these three options. Let's stick to enterprise and we can choose AWS as our cloud provider. You should choose the region that is closest to your data center, but for now I'll just choose Virginia. Snowflake will ask a bunch of survey questions to understand the reason of your account creation and to serve you better. I will just keep these for now. You can check them out and we are signed up. You will get an email to the mentioned email ID. The email should look like this. Click and activate. You will be asked for the username and password. Provide that and you are good to go. Snowflake is asking for my preferred language and will provide a sample dataset for practice. I will skip it for now. And now this is the UI you should see as well. If you click on data and databases, you should see these two. Let's click on create and choose SQL worksheets. Right now no database is selected. Here we are going to create our database. We will create the schema and inside that we will go ahead and create our tables and other objects. We will also create a user using which we will load the data, and we will also do ad hoc querying, and we will also use the same user to access data from Power BI as well. For the sake of ease, in this video I will grant the user the account admin access, which means the user will have complete privileges over everything. So now that we have created all the files and the Snowflake account, let's move forward. I was reviewing the code and I noticed one issue which I have fixed. The slash in new line character was incorrect in my code, as you can see here. So I had to make this change in customer and store script, and after that I have regenerated the file. If you were practicing along, maybe you already caught it. If not, you can fix it now. Another change that I have made is I have moved all the files in their own directory for clarity. We saw in our last script how we can generate the output file in a specific directory, so I think we should be good. I'll show you the directory structure shortly. So let's start creating the objects in Snowflake. In the interest of time, I've already created these statements, but I'll explain everything as usual as we move forward. So first we are going to create our test database where we are going to do all our operations. So the test DB has been created successfully. We do not see it on the left hand side. If we click these three buttons, we will start seeing it. By default, Snowflake creates these two schemas. Information schema, it captures a lot of meaningful information related to the operations and the metadata. Let's go ahead and create our schema as well. We will do all our operation inside the test schema. So the test schema has been created successfully. If we refresh it here, we will see the new schema as well. Right now it does not have any objects. Let's go ahead and create our tables as well. So the first one we are going to create is dim_date. It has all those columns we saw earlier in our diagram, and then we generated data for them in CSV using our Python scripts. The table is created. Now one can argue, why are we creating dim customer first when it has the loyalty program ID? Well, I have not defined a foreign key on it just yet. But in order to stay correct and consistent, let's create the dim loyalty table first. Just remember that we do have a relationship between these, not defined explicitly as of now. So the dim loyalty has been created successfully. Now let's go ahead and create the dim customer as well. Notice these tables have the exact same columns we have already populated there. There is nothing new whatsoever. Okay. You remember related to the primary key column, I mentioned we will handle them in Snowflake. Well, this is how we will handle them. We will specify auto increment for this column. It will start from 1, and every time a new row is inserted, the value will be increased by 1. For all our primary keys, we are going to handle it in the same way. Let's create the dim customer table. It's created successfully. Let's go ahead and create the dim product. The same thing. Used auto increment for the primary key, and these are the exact same columns we populated in our CSV files. Nothing has changed. The structure we finalized in our sheet, we are sticking to that. Let's create dim store again. Same thing, auto increment for primary key, and the remaining columns we already know them. Let's go ahead and create this. And finally, let's create our fact table, fact orders. Here order ID, the PK will auto increment. We have all these foreign keys. We have defined them explicitly here at the bottom. All these columns are referring to these tables, And again, we have defined them explicitly, and then we see all these measures. So let's go ahead and create our final table as well. So till here our tables are created. So if you see, we have the 6 tables that we initially saw in our ER diagram. Before we start loading data into these tables, there are a couple of things we need to do. We need to create a file format. So we need to tell Snowflake that the files we will load into our tables, they will follow a specific format, and we are going to create a stage. What is a stage? So stage in Snowflake is a location where data files are stored for loading and unloading the data. Please do not confuse it with the staging in data warehouse. This is the location, and that usually is a schema in a database. The stage can be external or internal to Snowflake. For example, you can choose to store these files on AWS in S3 bucket. For now, to minimize complexity, we will store these files in a named stage internal to Snowflake. Let's go ahead and create our file format. This is how it's going to look like. We will write create or replace file format. Then we'll specify the name of our file format. We will specify that these will be CSV files and they'll have a header. Also, just to be on the safe side, I've specified that my columns may be enclosed in the double quotes. It's not mandatory. And then the date format. If you remember, when I opened the CSV on my local, the date format was DDMMYYYYY. But Snowflake, being the smart tool that it is, while loading will automatically convert it into YYYYMMDD. If you see a different date format at your end, you can always change that value here. So we have created the file format. Let's refresh and validate the file format. It was created. And now we are going to create the stage as well. The syntax is simple. This is where I'm going to place all my files before we actually load this into our tables. The cool thing with Snowflake is that you can actually query these files as if they were tables. I will show this when we move to our ad hoc query section. So we have created the tables, file format and the stage. Now it's time to load them into the stage. At the moment, all these files are present on my local system. We need a mechanism to push them to Snowflake. We can upload them through the UI as well. But for now, we are going to use NoSQL, which is a command line tool to interact with Snowflake. We will use the put command inside it to push these files from the local machine to Snowflake. The command is very straightforward. You write the keyword put followed by the location where the file is stored in your local machine and the name of the stage along with the @ symbol. Here we have specified the complete name of the stage, database.schema.stage. Now let's download SnowSQL so that we can push our files. If you write SnowSQL download, you should land on this page. I will also drop a link to it in the description. You can choose the version based on your OS. I'm on Windows, so I'll choose this and the download will start. I've already installed it, so I'm not going to install it again. The installation is a very straightforward process. If you face any challenge, then please post in comments and I'll create a video on it. Now connecting to Snowflake from SnowSQL is also a very straightforward process. You write Snowflake-A in your command prompt and then you just specify the account name. Where would you get the account name? You can get the account name from the Snowflake UI. You have to click here and then hover here and then you copy this. We do not need the HTTPS and the last part, just till the location of the Snowflake instance should do it. Then you specify the username and password and it will connect you to your account. Now you see no database is selected. So you have to explicitly choose the database first. You can do that using the use command. Similarly, let's choose the schema as well using use command. Now we are at the right place. Before we execute something, we need to ensure we are using the appropriate role that has all the required access. For now, I'm using account admin that has all the privileges, but ideally we should restrict this role to a very limited set of users. Now let's copy the put statements and we will start executing it one by one. Before we load anything, let's verify that our stage is empty. Notice after the stage, I've specified dim loyalty info. This would create a folder in our stage with the same name, and the file will be stored inside this folder. You may have also noticed that I've used auto compress is equals to false because Snowflake by default zips and compress the files. I do not want that, which is why I've added this. Now let's paste it here, and we can see that the file was loaded successfully, no compression, and the upload was successful. Let's go ahead and load the other ones as well, one by one. Notice each one of these will be loaded in a separate folder in our stage, which I've specified here. I'm going to give you all these commands and statements. You just have to change the location and you can execute them. Although I'm hoping that you are following and coding with me and you will be able to do everything on your own. The fact table has large amount of data, so it will take a few seconds and it's done as well. Notice for the 100 files, we have not specified the name explicitly. Rather, we have used the wildcard star so that all files are uploaded. Let's run this as well. Because we have a large number of files, it's going to take a few seconds and all the 100 files have been uploaded. Let's re-verify in our stage. Upon refreshing, we should see the new structure and all the files we just uploaded. This is the case. So now all our files are available in Snowflake from our local, but they are yet to be loaded in our tables. Let's verify this, and yes, we do not see any data. How are we going to load data from stage to our tables? We're going to use copy command, and the syntax is very straightforward. We specify copy into the table name where we want to copy the data and the file from where we want the data to be copied along with its stage location. We also specify the file format that we created earlier. So here we are loading from the file, so we also specify the file format. This is pretty similar to insert into table in our standard DBs, but instead of loading data from a table, here we are loading from a file. So let's run this command, and the data has been loaded. 5 rows were loaded and no errors were observed. Let's verify the data, and we see the correct data here. Let's move on to the customer. Now you may ask, why I've specified the names here and not in the above one? Well, this is because we are using auto increment for our primary key here, so that column is not present in our CSV file. If we perform the copy, Snowflake will throw an error stating that the number of columns in file is 1 less than that of the table. In order to tackle that issue, we have specified the column's name explicitly. Rest everything remains the same. I hope it's clear. So let's go ahead and load the dim customer now, and it was loaded successfully. We have 1000 customers now in our table. Let's verify that. We will do the same for products. 1000 rows were loaded for products as well. Let's see them. This actually looks really cool, right? Let's go ahead and populate our data as well, and we have the dim date also here. Let's load dim store as well. We have 100 stores and the same were loaded. Look at these names, really cool, right? Notice one thing. We said our business started 10 years ago, but some of these values are way before 10 years. So as a part of our ad hoc query, we will fix this and a few more things. We will have another query for the fact orders as well. A lot of exciting stuff is still pending. Let's load the fact orders as well, and even though it had 1,000,000 rows, it was loaded really quickly. Let's verify this real quick. We'll set a limit of 100 rows, otherwise Snowflake would try to bring large amount of data. And finally, let's load the 100 files as well. Here the only difference is we just specify the folder name and no file name, and Snowflake will load all the 100 files. We can see that all the 100 files were loaded successfully. We did not see any error. Let's re-verify, and all our data is now here. Now we will have to generate a user that we will use to connect to Power BI and for our ad hoc query. So this is the syntax to create the user. I've explicitly specified that the user will have to change password on login. The default role will be account admin, and by default, the user will use the compute warehouse as the warehouse. Let me run this, and the user is created. Let me grant the account admin access as well. This is also done. Now let's sign out and log in through the new user we just created. Let's specify the username and password. And now let's specify our new password. Let's confirm this. And now we are logged in. We'll create our first SQL worksheet for this user. This is where we will write our queries. And let's look at the first problem statement of our query. We started our business 10 years ago. So all the store opening date should fall in this video. We need to run an update statement and do the same. So we need to populate random dates in this last 10-year time period. So any date between 1st January 2014 and the current date. Now we do see the problem in our data. We have values way older than 2014. How do we ensure that we have values 1st Jan 2014 onwards till July 2024? Well, we can use date add function to our help here. See, we need values 1st Jan 2014 onwards, right? So if we add 100 to 1st Jan 2014, we got 11th April 2014. If we add to 3000, we got a value from 2022. So if we can add a random value to 1st Jan 2014, that should solve our problem. But what should be the maximum value that we can add so that we do not cross our current date? Well, for this we can use date diff to check the difference between 1st Jan 2014 and the current date. We got 3863 as the value. We need to make sure that we do not have a value which is greater than this. But for our case, let's not use this as well. Let's say we did not open any store in the last 60 days. So we will use 3800 as our upper bound. Now we know the date, we know the lower and upper bound, but how do we generate a random value between this in Snowflake? Well, we can use the uniform function. We will specify our lower and upper value and it will generate a random value between this. Let's execute it. Oops, I missed the bracket. Let's add it. And now we are getting the correct dates. Let's verify it couple of times and I think we are good. Now we just have to plug this in our update statement, update table name, set column name, and let's copy paste this and we will execute it. We see that our 100 rows have been updated. Let's verify them real quick. They look good. Let's commit this and we can move to our next query. The next query is fairly straightforward. We have to update the store table again and we have to update it for stores with ID between 91 and 100. We have to update it in a way that their store opening date should be in the last 12 months. Let's move back to Snowflake to write our query. So we need to update dim store again, and as we saw, we need to update it where the store ID is between 91 and 100. So this should be our where clause. So here also, if we can find our date 1 year ago and add random values between 0 and 365, we should be good. Let's use date diff to find our exact date 1 year ago, and this will be our start date. Now let's add values up to 360 only so that we have at least a few days for our stores to have some orders. Let's verify this and it is generating the expected dates. Let's go ahead and plug this in our update statement. We will remove this select, we'll run it, and this looks really good. So now our second query is also complete. For our third query, we need to update customer table so that any customers that are less than 12 years old, we subtract 10 years from their date of birth. Just for data testing and learning purpose, right? Nothing real or personal. So let's do a select star from our dim customer table. Now here we need to identify records where the date of birth falls in the last 12 years. So let's use date add year and -12 from our current date to get the minimum date. So we did get a few rows. This is our where criteria. This is where we need to perform our update. Let's write our update statement. We will specify the column name DWBI and our where criteria. Now we need to update date of birth on the basis of date of birth itself. We just have to reduce it by 12. So we should write date add year -12 and the date of birth column. And with this, we can go ahead and execute our update statement. Let's verify by executing our select query, and our result looks as expected. Let's go ahead and commit this, and with this our third query is also complete. So we have updated all the stores to have the opening date past 2014, but we still have dates in our order table that are before 2014, which is incorrect, right? For example, a store that was opened last year, we cannot have orders for it from 10 years ago. If we see, we have these order ID listed here that have order dates before the store opening date itself. So we need to correct such orders to have the order date between the store opening date and the current date. Let's write a query for this in Snowflake. So this will be a 3-step process. First, we identify the orders that have a problem. Then we identify a date between the store opening date and the current date. And finally, we update it in our fact orders table. So let's get started. We will first join our fact order tables with dim date, because fact order has the date ID while the store dimension has the actual date in it, so we cannot join it directly. So we will identify the date based on our date ID from the fact table. Let's join the fact with date on the date ID, and now we will join the fact with store on the store ID. Now we only need those records where the date ID from orders or date from our date table is less than the store opening date, which means that the order date is before the opening of the store date. Let's run this, and we have around 50k rows that have a problem. Let's pick specific column names for more clarity. We will choose the order ID, date, store opening date from our store table, and let's also choose the store ID. So you see, we can verify the problem now. Now our first step is complete. We have identified the rows that have problems, right? Now ideally, we only need the order ID and the store opening date, because on the basis of these two, we will perform the update and get our new date. So now let's work towards getting the new date. For this, first let's identify the difference between the opening date and the current date. We will use datediff for this. Now we have the values as well. Now essentially we can add any value between 0 and this value, and we will have a valid date for this scenario. We will generate random value between these days using the uniform function. It will return a value between 1 and 10, and finally we will multiply this with 0.1 so that it does not cross our current date. Let's run this, and now these are the days we can add to our store opening date to get the new date. For this, we will use the date add function. We will specify day, these days that we want to add, and the store opening date. And now we have the new date as well. Actually, we need an additional step. Since our fact table has the date ID, we need to transform this date into date ID. Now there are multiple ways to do it. In fact, there are multiple ways to write this query. If you wrote it differently, please do specify your query in the comment section as well. I'm going to join this dataset with dim date to get the date ID based on our new date. Let's perform the join on the basis of date and new date. And now we have the date ID as well. All we need to do is update the fact order table with these new dates. And we are going to do this on the basis of order ID column. We will specify update fact order, set date ID is equals to date ID. Let's specify the alias as well, otherwise we'll get an error. Let's call it R instead of O, as this is a reference based on which we are updating our orders table. This is our where condition, f.order ID is equals to r.order ID. Let's run this, and all the rows have been updated correctly. Let's commit this. If we run our base query one more time, it should not return any rows, and that is the case. With this, our fourth query, which was a little more complicated, is also complete. The query number 5 is very straightforward. We need to find customers who have not placed any orders in the last 30 days or last month. If we can find the customers who have placed the order in the last 30 days, then we can exclude them from our customer list and that should give the customers who have not placed any orders. For this, we will join our customer table with the fact orders table using customer ID, and then we will join our fact order tables with the date table using date ID. This is required so that we can filter orders placed in the last month. We will specify our filter condition using date add. This is going to filter the records, and this is how the syntax would look like. These are the customers who have placed orders in the last month. Let's exclude them using a subquery and not in clause. We will write select star from dim customer where customer ID not in. Let's run this, and we got our result. These are the 4 customers who have not placed any order in the last month. The query 6 needs us to identify the store opened most recently and the sale it has done since then. This is a 3-step process. Identify the most recent store ID, get its sales, and then fetch all the attributes for the store. There are multiple ways to solve this. We will solve this using with clause. We will calculate the rank using row number and order by clause. This will give us the store wise rank. Let's add store opening date as well to verify what we wrote is correct. Now we just have to filter the data where the rank is 1, and we got the store ID 91 as our store, right? Now let's calculate the sum of total amount by joining with the fact orders table. We will join this using the store ID column. Let's group by store ID, and then we'll take the sum of total amount. This is the total amount sold since the store opened. Let's join this with dim store one more time to get the attributes of our store. We will join this with dim store. This is how the query will look like. We'll get the values from dim store and the total amount from here. And this is how our final output will look like. So let's move on to our next query. Here we need to find out customers who have ordered products in more than 3 categories in the last 6 months. So first we will identify the orders placed in the last 6 months. Then we will associate the category of those products with orders. And finally, we will group by the customer ID and identify which customers have ordered more than 3 unique category products. So as you have noticed, I've joined orders with date to filter the last 6 months records. And then I've joined with dim product on the basis of product ID to map the category. Now we have the customer ID and the category, the customer ordered. Let's call this our base data. We will use group by along with having to get our result. We know the customer need to order more than 3 distinct categories. So we will use having count distinct category is greater than 3. And now we get the customer IDs which have ordered more than 3 categories in the last 6 months. In the next one, we need to display month-wise sales for the current year. This is very straightforward. We need to first filter our orders for the current year. Let's join our date table again using date ID, and now we can specify where year is equals to. We will extract the year from the current date, and now we have the data for the current year. All we have to do is group by month, and we can take the sum of total amount. Now we have got the month-wise sales as well. Let's order these correctly using order by clause, and look at that number in the current month. It's really high. For the next query, we need to calculate the maximum discount offered in the last 1 year. Again, we will have to join our orders table with the date table. Let's copy paste this code here, and now we need to filter for the current year. We can use date add for the same. We will specify year -1 and the current date, and now we need the discount amount, and we'll calculate the rank based on our discount amount using the row number function. Let's do the same here quickly, and now let's give it an alias base underscore data. We will use our with clause. All we need to do now is filter the row where the discount rank is equals to 1, and we got the maximum discount amount. The 10th one is also very simple. We need to calculate the total sales by multiplying the quantity and the unit price. Here we will join fact orders with dim product on the basis of product ID. Then we will multiply unit price with the quantity ordered, and finally we will take this sum to get our final results. For the 11th query, we need to show the customer ID of the customer who has availed the maximum discount in the company's lifetime. So we need to show the customer ID. Let's get this info from our fact orders table. We are going to group by customer ID, and then we are going to take the sum of discount amount. We do not need this limit here anymore. Speaking of limit, let me show a method which I usually never prefer when I write my actual queries. That is to restrict the number of rows using limit. So I'm going to order by sum of discount amount, and I'm going to limit the row output to 1. Let's remove the discount amount, and this is the customer that has availed the maximum discount in company's lifetime. I just wanted to show you this, though I never prefer it myself. I usually prefer rank or row number for such situations, and we will see that in the next query. In the next query, we need to display the list of customer who has placed maximum number of order till date. So here again, we need our fact orders table. We are going to group by our customer ID, and then we will take the count of our order ID. Right? Now we can do the same. We can order by our count of order ID descending, and we can keep the limit as 1. That will give us a single row, but we do not want that. Rather, we are going to use a with clause here. Okay. And we are going to use rank along with this. So let's call it with base underscore data as, right, this is going to be the alias of this query that we wrote here. And then we are going to calculate the rank on the basis of order count. So let's write select star from base data. Okay, we'll call it b dot star, and then we are going to use row number to get our rank. So we'll specify row number over order by order count descending, and then we can give it an alias again, right? And finally, this query that we have written, we will give another alias to this query, and then we will specify select star from our alias where order underscore rank is equals to 1. And that's how we are going to get the customer ID who has placed the maximum number of orders. For the next query, we need to show the top 3 brands based on their sales in the last 1 year, right? So when we have to filter the data for the last 1 year, we know that we'll have to join it with our dim date dimension. So we are going to join our fact orders with dim date on the basis of date ID, and we are going to add the filter condition where date is greater than equals to, we will specify date add year -1 and the current date. Now this is going to give us the orders that were placed in the last 1 year. We know that our brand is part of the product table. So we are going to join with our product table, the dim product, and we are going to join on the basis of the product ID. Now we are going to group by on the basis of brand, and we are going to take the sum of total amount. This is going to give us the total amount spent or the total amount bought for each brand, right, in the last 1 year. We do not want to show everything. We just want to show the top 3. So what we are going to do, we are going to give this an alias brand underscore sales, right? And then we are going to again calculate the rank on the basis of our sales. So we will use our row number function for it. We are going to specify row number over order by the amount column, right? This is going to give us the rank. Let's also give this query an alias, and finally all we have to do is we have to select the data set and specify where rank is less than equals to 3. So it's going to give us the 3 records 1, 2, 3. These are the brands, and these are the sum that people have bought from these 3 brands. So currently we have calculated the total amount based on a variable value of discount and shipping amount. What if these percent were fixed at 5 and 8% respectively? Will the new total amount be greater than the current database total amount, or will we make less money? So this actually is very straightforward. We need to fetch data from fact orders table, and while taking the sum of order amount, we need to subtract the order amount based on the new percentages. For discount, we will multiply by 5% or 0.05, and for shipping we will multiply by 0.08. So this will be our new amount. Let's calculate the DB amount as well by taking the sum of total amount. We will call it original amount. Let's run this. The new amount is higher. Let's comment the limit statement to avoid confusion. And now we can use a case statement. If the new amount is greater than the original amount, then yes, else no. And we got our answer. For the next one, we need to show the customers and their current loyalty program status. This is also very easy. We need to join the customer table with the loyalty table on the basis of loyalty program ID. Then we will group by program tier and we will take the count of customer ID, and this will be our solution. For the next one, we need to show the region and category wise sale for the last 6 months. Here we need to join 4 tables. Fact orders has our base data. We will join it with dim date to filter last 6 months records. Then we will join it with dim product on the basis of product ID so that we can get the category information. And finally, we will join it with dim store on the basis of store ID to get the region. Now that we have this filtered information, we just have to group by on the basis of category and region, and we will take the sum of total amount. Let's call it total sales amount, and this solves this particular query as well. For the next one, we need to calculate the top 5 product based on the quantity ordered in the last 3 years. Again, a very straightforward query. We need to join with dim date to filter the last 3 years record. We will group by on the basis of product ID, and we will take the sum on the basis of quantity ordered. Now we will use it as an alias in our with clause, and we will calculate the rank on the basis of quantity ordered. We will give an alias to this query as well. And finally, we will filter the records where the rank is less than equals to 5. And this is our result. For the 18th query, we need to list the total amount for each program tier since 2023. Here we need to join 4 tables. Our fact orders has our data. We need to join it with date to filter the records post 2023. And then we need to join it with customer table because loyalty and fact are connected via the customer table. We will use customer ID to join the fact table with the customer table and the loyalty program ID to join with the loyalty table. Because these queries are quite similar, so I'm solving them quickly. We already have and we'll also have plenty of videos on query solving in future as well. Let's filter the records so that the year is greater than 2023. Now we just need to group by program tier and take the sum of total amount, and we got our answer. For the next one, we need to calculate the revenue generated by each manager in the year 2024. Again, a similar query. So let's copy and paste the above query here. We'll make changes to it. We need to join with the date to filter the data, and then we will join with the store table to get the manager name. Finally, we will group by the manager name and take the sum of total sales to get our solution. This is how our query is going to look like. And this is our final output. For the 20th query, we need the average order amount per store per order, and we will also need to show the store name and store type for the year 2024. We can copy the above query for this one as well. Let's make changes to it. We only need data for the year 2024. So let's change the filter. Now instead of manager name, we need the store name and the store type. Let's list that. And instead of taking this sum, we need to take the average. Let's change that as well. And we got our solution. I will post more queries for practice in the comment section so that you get a plenty of hands-on experience. So for these next 5 queries, we are going to retrieve data from files and not from tables. So the files that are stored in our stage, we'll see how we can query them. For the first one, we are going to query the data from our customer CSV file that is already present in the stage. I've already written the queries. I'm just going to show you them and walk you through them. So it's very straightforward, right? You have to specify your column names along with the dollar symbol. So $1 would be the first column, that was first name, $2 was last name, and so on, right? Then select from. Now instead of the table name, you have to give the absolute full path of the location where the CSV file is stored in your internal stage, and finally the file format that should be used while reading the file. If I'm going to run this query, right, it is going to give me the first name, the last name, and the gender, which is my third column. So it's as simple as that. For the next one, we are going to aggregate data, right? We are going to share the count of records in the dim customer file that is present in our stage. Everything else remains the same. As far as aggregation is concerned, we just aggregate in the same manner we would do with a table. We specify our aggregate function. In this case, it would be count, and then we specify the column name, right? Select from the location where our file is present, and the file format that remains the same. Now I'm going to run it, and it's going to return the count of records that I have in my customer file, which is 1000. So this is actually very helpful. If you want to get a feel of your data before actually loading it, you can run this query and see how your data looks. For the next one, what we are going to do is we are going to filter the records from the customer file. So we have selected in the first query. In the second one, we did aggregation. Now we are doing filtering, right? So we are going to filter where the customer date of birth is after 1st January 2000. So here I've selected 6 column. I can go ahead and select more as well, right? 7, 8, 9, whatever columns that are present in my file, they'll be displayed in the same order. I know my 4th column is date of birth. So how I would specify if it was a table, in the very same manner I've specified my where clause, where my column name is greater than this. And if I go ahead and run this, I will see records where the date of birth is after 1st Jan 2000, right? So we have seen how to select, we have seen how to aggregate, we have seen how to filter. Let's also see how we can join data from multiple files, and for this we are going to use with clause. So we are going to give an alias to these files, and then we can treat them as actual tables, the same manner we would treat any regular table, right? So here what we need to do is we need to join the dim customer and dim loyalty, and we need to show the customer first name along with the program tier they are part of. So the customer first name and the program tier. The first name is present in the dim customer data file. So again the same thing, I've given an alias. The alias are allowed here. So I've given an alias to my first column, and I know my 12th column is loyalty program ID. So I've given alias for both of them. Rest everything remains the same. I've given a name to this query, this CT, right? I've given it the name customer data, and I've written another query and I've given it the name loyalty data. Here I'm fetching 2 columns, the loyalty program ID and the program tier, right? Now, as we have done in the last 2022 queries, all we need to do is we need to join our customer data and loyalty data on the basis of loyalty program ID, and we need to show our first name and the program tier, and this is the result that we got. So we have selected the data, we have filtered the data, we have aggregated the data, we have joined 2 files. Let's also do a group by on those files and see some results. So here the only thing that has changed, right? The customer data remains the same, the loyalty data remains the same. Instead of showing the customer name, we are going to get the count of customers in every tier. So everything else remains the same. We just added a group by here and a count here, and we named it total count. So if I run this, I'm going to get the number of customers in every program tier. So this was very similar to how we would do it in our SQL, right? The good thing is Snowflake allows us to query files, data files, which was not the case with majority of our traditional DBs. So with this, our query section is complete, and now we will create a report using Power BI. But before we actually log in to Power BI desktop, we are going to create a blueprint of the report, and we will see why it is important to create the blueprint first before the actual implementation. So let's start creating the blueprint of our dashboard. We will see the steps involved. First, we will show the key metrics and visuals that we plan to list in our dashboard. We'll start with our cards. So we'll show total sales, total orders, total customers, the average order value, total discount, the shipping cost. From there, we'll move to the filters. We are going to show 3 filters: region, category, and date. Right? So these are the cards that we are going to show. These are the filters. What about the visuals? So we'll create a pie chart that will show the amount by store type, a line chart which would show the amount with the region and year, a clustered bar chart, a donut chart, a funnel chart, and a tree map. Right? So we'll show some cards, we'll have some filters and some visuals. In order to achieve this, we need certain measures and calculated columns. These are the measures that we need: the order amount, the total orders, the discount amount, shipping cost, customers, and average order value. We also need couple of calculated columns. This is how we are going to calculate our age on the basis of current date, and on the basis of the age column, we are going to create our bucket or grouping. Right? So these are the columns and measures that we'll need. Now our dashboard will have 4 sections. In the first one, we'll have the header, logo, and filters. In the second one, we are going to show the key metrics. In the third one, we are going to show the amount segregation by store type, time series, and region. And in our fourth section, we are going to again show the amount segregation, but this time by program tier, age group, and category. We are going to use the font Calibri and theme accessible title in creating our dashboard. This is how the dashboard is going to look like. Obviously, it's not very pleasing to the eye, and it's very limited in terms of functionality as well. But the main agenda of this video is to show how the implementation is done. A proper, aesthetically pleasing and a functional dashboard deserve its own video series, and I'll work on that later. But in this video, you will get a feel how the dashboard is created by fetching data from Snowflake through a meaningful data model. So let's switch to our Power BI desktop, and we will start pulling our data from Snowflake. So let's click on Get Data. We will click on More. We will write Snowflake. Then we will select Snowflake and we will click on Connect. We will have to specify the server name. We do not need HTTPS. Let's remove that. We will specify compute_warehouse as our warehouse name. We will use account admin as our role. And then we will finally write test_db as our database, although it's optional. Let's click OK. We will have to specify the username and password we created. Let's do that here. And we will click Connect. Now we will see all the databases that the user has access to. Let's click on test_db. Let's select our schema, and then we will select all the 6 tables we created and populated data in. Now instead of loading the data directly, we are going to transform the data to make some minor changes. We are going to use the import mode for better report rendering performance. Now you can see that Power Query or Power BI is consuming order ID, date ID as decimal point. We know that in our database these are actual integer values, so let's go ahead and change them. So I'm changing all these decimal points where I know it's not required to a whole number. Let's perform this operation for the other columns as well quickly. These operations that we are performing right now are getting performed in Power Query, which actually executes M language in the background. It has a very cool interface, as you can see, that allows us to make a lot of changes simply, but you can also write complex code using M language. Okay, so let's quickly make this change. You can see this is weekend is a boolean here, right? We will change the year to whole number. Let's move to our final one, which is dim customer. We will change the customer ID to integer or a whole number. And finally, the loyalty program ID, right? Let's change that also to an integer. Now we are going to close and apply, and the load from Snowflake to Power BI desktop will start to happen because we have chosen the import mode. So the entire data that is present in these tables in Snowflake is going to get downloaded here on my local desktop in Power BI, right? As you can see, the download has already started. It has completed for majority of my dimension tables, but since my fact table has a huge amount of data, that load is still happening. So see, we did all this, right? We created these tables, we loaded huge amount of data, meaningful data using Python, right? And now we have moved towards Power BI where we are loading this in the data model. So after this, we will go ahead and create our data model as well. Let's move forward. So we'll go to our model view. Before that, let's just quickly see the data. So we have all these 6 tables with our data, and this is how our data model is look like. If you go to the manage relationship, you will see all the relationship that exists, right? We have the one-to-many relationship as we saw in our ER diagram, right? And all these relationships are active. So our data is loaded, our data model is finalized. Now all that is left is for us to create the visuals that we had finalized in our blueprint. Let's go ahead and do that as well. Let's create the 2 calculated columns first. We will have our age column, and for that we are going to use date def. We are going to calculate it on the basis of the current date. We will subtract the date of birth from current date, and we will extract the number of years, right? And this is how we are going to calculate our age column. On the basis of the age column, let's create our bucket or grouping as well. So we will use our age column, and we will use a bunch of if statements. If the value is less than 18, it's minor. If it's between 18 and 25, we would specify a string between 18 and 24. Similarly, we will specify the other strings as well. And now on the basis of our age, we are going to get a new column with these values. When the value is less than 18, it's minor. If it's 22, it's between 18 and 24, and so on. So both our calculated columns are now complete. Let's create the measures as well. The measures are pretty straightforward. We are going to create it under fact orders. The first one is total order amount, which is sum of total amount, and we are going to show it in the dollar currency. The next measure is total orders, which is the count of order ID, right? Straightforward, the number of orders that have been placed, that is going to be shown through total orders. The remaining 4 measures are very simple and self-explanatory. The first one is total customers, which is the count of total customers that we have. Then we have the average order value, which is the average of the amount. We have the total of the discount amount, which is the sum of discount amount. And finally, we have the shipping cost, which is the sum of shipping cost. So let's go ahead and create these 4 measures quickly as well. Now that the measures are created, let's go to our model view, select all these measures and group them
and display them under a folder named measures. This would ensure that they are easy to track and maintain. And once this is done, let's move to our actual report and start creating it. The first section that we have in the report is our header. Let's go ahead and create that. So in our header section, we'll import an object. This is not the color we want, so we're going to change our theme. We'll click on view and we will select accessible title. Now this looks good. We'll have to insert a text box where we'll specify the name of our dashboard, which is orders overview. Let's change the font to be Calibri, right? And let's change the size to be 14. Now we'll push this text box inside the object. We have removed the background and we have changed the font color to white, and this looks good. Now let's go ahead and select our first card visual. We are going to show total order amount. Let's change the font and the size, right? We are going to specify the title of our card, total order amount. Let's place it here. Let's finalize the layout of our card section. We will import an object. Let's resize this a little bit. Let's push this section to the back so that we can see the values. Let's change the fill of the section to white. We also have to give a background color to our page. Let's do that. Let's choose our color. Now we still see the white color, so we need to increase the transparency, and this looks good. Now we need to remove the background from our card visual. Let's go ahead and do that. Let's make some more minor changes and then we'll make copies of our card. Now that our first card is finalized, let's go ahead and create 6 copies of our card. We are going to select these cards and we are going to distribute them horizontally and vertically. Now let's go ahead and change the measures in these cards one by one. This second card is the total number of orders. The third one is the total number of customers. The fourth one is the average order value. The fifth one shows the discount amount. This sixth one shows the shipping amount. Let's go ahead and change the decimal points of the total order value to 2, and this looks much better now. Now we will go ahead and change the title of each of these cards. The second card shows the total number of orders placed. Let's name it total orders. We will also change the decimal point to 2 decimal point. This looks better. Now for the third one, let's change its title to total customers. For the fourth one, we will specify average order value. For the fifth one, we will specify total discount. And for the final one, we will specify shipping cost. So now our 6 cards are ready and the second section is complete. For our first visual of the third section, we need to show the total amount by store type using a pie chart. Let's create it and let's resize the visual and change formatting. We will move the legend to the top left, and let's also change the data label to only show % of the total. We will resize it further and change the title to amount by store type. The color of these slices are not looking good. Let's change them as well so that they meet our blueprint specs. We will also switch on the border, and now this looks much more reasonable. Let's also change our font as well. We'll go ahead and create a copy of this visual, and we will create our line chart that will show the total sales by region and year. Let's add the year to the x-axis and the region to the legend. The total sales can stay at the y-axis. Let's switch off the title for the x and the y-axis, and we will add the markers to our data points on the line. We will also change the color of our lines so that we have a consistent layout in all our visuals. Let's go ahead and change the color of all 4 lines, and now our line chart looks much better. Let's copy our pie chart one more time, and we will go ahead and create our third chart as well. We will change the chart type to clustered bar chart and the x-axis to region. Let's also change the individual color of the bars to match the other visuals. We will switch off the title for the X and the Y axis. And let's also change the title of our chart. Now these three are looking close to what we had in our blueprint. We had missed out on changing the title of our second visual. Let's go ahead and change this, and this has started to look much better. Let's adjust the position and size of our visuals. We can see that our visuals are interactive. Now that we are done with the initial three, let's copy and create our fourth visual as well. I think we can improve the spacing between our visuals a little more. Let's select them and move them a little down. Let's select all the cards and the container and move these as well. And this looks a little better. We'll create the donut chart as our fourth visual, where we'll plot program tier. Let's go ahead and do that. Let's change the color of all our slices to keep them consistent with the other visuals. We will adjust the size so that all the legends are visible, and we will keep the above charts in sync and adjust them as well. The title of this chart will be amount by program tier. Let's make this change, and now the fourth visual looks good as well. In the next visual, we are going to plot the order amount by age bracket column we calculated earlier. So let's go ahead and copy the second visual. We will paste it here. We will change the x-axis to age distribution, and we will remove the legend as well. Now ideally our funnel chart does not make sense for this dataset, but we will utilize it in a way so that it looks good and delivers meaning. We will remove the conversion rate and we will add the data labels, and this looks much better. Now we will change the title of this visual, and even this part is now complete. For our final chart, we are going to create a tree map, and we are going to create it on the basis of category. Let's copy the third visual and let's change it in a tree map. We will change the category to be from our product category. Let's also change the font as well, and finally we will change our title. And with this, all our visuals are now complete. We can now add the filters at the top. The first filter we are going to add is on the basis of region. We will select the style as style from our slicer settings. Let's resize this. We will also close the slicer header and the background. Finally, let's resize and format this some more, and we will put it at the top right of our report. The next filter will be category from product, and we are going to use a drop down style from our slicer settings. Let's put it at the top next to our other filter. We will change the font and size of our slicer header and the value. We will also remove the background of the visual. But now our values and slicer header is not visible clearly. So let's change these colors as white. Now we see we are not able to see the values when we click on the drill down. For that, let's change the background of the values to have the same color as our title, and this looks much better. Let's move it a little to the right, and we will create our next and final filter by copying this visual. We are going to use date from the date table, and instead of using a drop down style, we will use the between style. Let's change the font and the size, and we will also resize and reposition our filter, and now this looks better. With this, we have created all the three filters as well. Now let's get our final logo as well. We will click on insert image, and then we'll pick our logo. Let's resize this and put this at the top left of our report. With this, our report is now complete. From a 2-line statement to this report, we have traveled a long way in this video. Now we can make 1,000 changes to this report to improve its look and feel and the functionality. The same goes for the other aspects discussed in this video as well. Let's do a final recap before we close. So we talked about an actual project architecture. We talked about entities, relationships. We created an ER diagram. From that, we generated our table structure. We talked about star and Snowflake schema. We pulled data from Oracle using Python. We generated a lot of test data using Python. We used pandas, faker. We read data from Excel and we generated data into CSV. Then we moved to Snowflake. We created the Snowflake account. We learned about the basics of Snowflake. We created our database, schemas, tables. Then we loaded data into Snowflake. And then we wrote our 25 ad hoc queries. We learned a variety of scenarios. We learned with clause and analytical functions. From there, we moved to Power BI. We created the blueprint. We connected Snowflake with Power BI. We made certain changes in Power Query. We looked at the data model. And finally, we created the report. In case if you still are here watching this video, please consider sharing it with your friends. Thanks a lot guys for watching this one, and I'll see you in the next one.